So, as the title suggests, the subject of this particular webinar is what's new in Java. And obviously there's a lot that has changed in Java over the last couple of years. So what I want to focus on in this webinar is the features which are relevant to developers. So there are lots of things that have changed in terms of the JVM, in terms of some of the garbage collection, in terms of some of the other parts of the JDK itself. But what I'm going to do is I'm going to focus on, if you're a developer writing applications, what things are going to be really useful to you in terms of the newer versions of Java. And again, because there's so much material that we could go through and the webinar time is limited, I'm going to go from JDK 10 onwards. Obviously JDK 9 was the last major release of Java, introduced modularity, and I think that because we've seen modularity for quite a long time and we've discussed that in the past, so I'm not going to talk about that in this presentation. I'm going to look at what's happened with the new release cycle. Now, at the beginning of all these presentations, I like to run a poll of you, the audience. And so if we can bring up the poll question here, what I'd like to ask you is, what is the most recent version of Java that you're currently using in your deployments? Now, I know that lots of people do use multiple versions, but I'm interested in what's the most modern one that you're using. And I've given you 5 possible answers here. First is if you're unlucky and you're still using some very old versions. So if you're using JDK 7 or older, then the second option is probably what I expect quite a lot of people to answer, which is JDK 8. Then we've got a third option, which is for intermediate releases, JDK 9 or JDK 10. Fourth option is the current long-term support release of the OpenJDK binaries, JDK 11, and then for those of you who may be on the sort of bleeding edge of adoption, JDK 12 or JDK 13. So 5 different options, giving you a few seconds to answer that. So hopefully everybody's now had an opportunity to answer that question. And let's bring up the results and see what we can see about that. So the results. There we go. Interesting. Okay, so as I very much expected, we have 71% who are using JDK 8. I did this presentation this morning for the European and Asian audiences, and that's very much in line with what I saw there. Interestingly, we've got a few people, 5%, who are on JDK 9 or JDK 10, which is definitely an interesting choice. 20% on JDK 11, few people still using JDK 7 or older, but nobody is on the bleeding edge using JDK 12 or JDK 13, which is interesting. Okay, so let's go back to the slides and get on with the presentation then. As I said, we'll start with the JDK 10 and we'll see what are the new features that are included in this. And clearly, as I said, what we're seeing now is a switch to a new release cycle where we get 2 releases of the JDK every year. Every 6 months, we get a new release. Now, the big thing in JDK 10 is the introduction of local variable type inference. What's that all about? Well, if we look at a very typical set of code that we use in Java, this is the kind of thing that we do a lot. We use local variables. Now, in the first case here, what I'm doing is I want a list. I want to store strings in a list. So I create a variable called userList, and I'm going to instantiate an array list for the reference that I'm creating. All very good. And in order to do that, obviously I have to say what type I want to instantiate with my new operator. And so it's an array list, but I can use the diamond operator to avoid having to duplicate the generic type parameter. And then when I define user list, I say that the type of user list is an array list of type string. And there's duplication there. I'm saying array list of type string and a new array list of whatever type that is. If I want to get a stream from that, then I have to explicitly state in my code that the stream I'm going to get back is a stream of type string. I can use variables in for loops. And so 2 examples here. The first is that if I take my list and I want to iterate over the list and retrieve the strings, then I can do the more modern for each style of syntax and say for string name over user list. And again, I'm explicitly stating the type. And if I use the older style of for loop, I can say for int I equals 0, I less than 10, I plus plus. All the kind of code that we're used to. In JDK 10, we now get local variable type inference. We can use var. And what that allows us to do is to say this. So rather than having to duplicate the fact that the user list is an array list, I can say var user list and then instantiate a new array list of type string, and the compiler will infer for me that the type of user list is an array list of type string. One very important point here is that you'll notice that I'm not using the diamond operator anymore. So I've actually had to put the generic type parameter in there explicitly. And that's very important because if you're going through your code and refactoring to use local variable type inference, be very careful if you have used the diamond operator, because rather than just changing the type of the variable to var and moving on, you need to make sure you change the diamond operator to use an explicit type. The reason for that is that if you don't, you get, in effect, double type inference. The compiler will infer the generic type parameter. And because there's no information on the left-hand side, it will infer the only thing it can, which is object. And so rather than getting an array list of type string, you'll get an array list of type object. And that means that if you then try and use that later on and you reference those objects that you extract from it and you think of them as strings, they won't be strings that you can actually process in that way. So you will get some errors. However, if we put the string parameter into our generic type, then the compiler infers the correct type that we want and everything works. Similarly, when we retrieve the stream from that, we can use var. We can let the compiler infer that. Because the user list is of type string, then the stream that's inferred will be a stream of type string as well. We can use var in our for loop where we're iterating over the user list. And once again, because the user list is an array list of type string, the compiler will be able to infer correctly from that var name, in that case, is going to be a string name. And then the last example, we could, if we wanted to, replace int with var and let the compiler infer for us that the variable we're going to use there is an int. Do not do this. It makes absolutely no sense. Var has 3 letters. Int has 3 letters. We're not saving anything in terms of typing. We're only saving things in terms of making our code more complex in terms of understanding, because we would have to think about that and go, oh, okay, yes, that is an int. So this is a good example of where not to use local variable type inference. And in fact, there are several more examples where you wouldn't use it. And Stuart Marks has written a very good document on this that you can find online. Stuart is one of the developers of local variable type inference, and he's gone through examples of where it's a good idea to use local variable type inference and also places to avoid using it. One place that makes a lot of sense is things like this. So try with the resources blocks. In this example, I've been very deliberate in making it very verbose, and I've replicated things a lot to make it seem more complicated. But it's a good example because, we like to use meaningful variable names. And so we can end up with something like this. I'm trying to create a buffered reader, which I want to use within the block. In order to get that buffered reader, I need to create an input stream reader. And in order to create that, I need an input stream. So this is all good, but we get lots of repetition. There's input stream, the type, input stream, the variable, get input stream, the method. Then we've got input stream reader, create a new input stream reader from the input stream, buffered reader, create a new buffered reader from the input stream reader. Lots of repetition makes the code very hard if you just glance at that to try and figure out what's actually going on. You have to kind of read through it carefully and see, that's how it's working. If we replace the explicit type definitions with var, we can tidy that up a lot. So if we look at that now, suddenly it becomes a lot easier to see, okay, we've got input stream reader, buffered reader, we can see what the types are, and it makes our code easier to read. And that's one of the key things really, because as I'm sure as developers we all know, you're going to spend more time reading code than you are writing code. And once you've written that code, it may well be somebody else who's looking at the code trying to understand what you've done. easier you can make it for them to understand, the better it is for them to be able to maintain it. So that's a very good example of where we can use local variable type inference. One of the things that I will say about the local variable type inference is that var is a reserved type, not a reserved keyword. And that's quite important, because if it was a reserved keyword, it would mean that we can't use var as a variable name anymore. And I'm sure that there's probably more than a few people who've used var as a variable name in their code somewhere. And if we then tried to recompile it on JDK 10, it would actually fail to compile if it was a reserved word. So in this case, it's now a reserved type. What does that mean? Well, what it means is we can still use var as a variable name. So we can have var equals new value added reseller. That's perfectly acceptable and will compile. What we can't do in JDK 10, which we could have done in JDK 9, but we never would have done, is create a class called var with a lowercase v. Now, in JDK 9, that actually would compile, and there's nothing wrong with it technically, but the convention is obviously that for classes, we always use an uppercase character as the first letter of the class name to make it clear what's going on. So in JDK 10, you can't compile that code. What you can do is you can still use var with an uppercase V, and that will compile quite happily. So case does matter. In terms of JDK 10, there were 73 new APIs that were added. A lot of those are quite esoteric, so I'm not going to go through all of them, but I picked out a few which are sort of interesting for general development work. And what you find is that several of these APIs are targeted around unmodifiable collections. In the case of the list, set, and map interfaces, each of those now have a new static method, copy of, which takes a collection. And what it will return is an unmodifiable copy of that collection. So either a list, set, or map, depending on which version you're calling. In that case, you won't be able to modify the members. Similarly, for the collectors utility class with streams, what you can now do is have a terminal operation in terms of a collector, which will collect to an unmodifiable list, map, or set. The last method that I've shown here is in the optional class, and that's a new method called or-else-throw. Now, this actually does exactly the same as the existing get method, but is a bit more explicit in terms of telling you what it does. So it will throw an exception if there's not a reference inside the optional. JDK 11. Now, JDK 11 is the current long-term support release of OpenJDK binaries. And as we've seen with the poll at the beginning, there's a gradual migration to JDK 11. More and more people are moving their applications to that. What things does that give us in terms of features? Well, the first is an extension of where we can use local variable type inference. And in this case, it's quite a small change, but what it allows us to do is to use local variable type inference on lambda parameters. Let's look at an example of what that is. So here I'm using a lambda expression within a stream, and I'm saying that I want to take some strings from my stream and I want to map those to lowercase. So I use a lambda expression which simply says s goes to lowercase of s. The interesting thing here is that lambda expressions already have type inference. We don't explicitly have to state the type of s. So we can leave s on its own, and the compiler will infer from the fact that the stream that we're creating from our list is a stream of strings, that when we map those things, that the s that we have in our lambda expression is going to be a string. We don't have to state that. What we can now do is we can use var. So we could say var s goes to s.lowercase. And of course you look at that and you go, why would I do that? It doesn't make any sense. There's absolutely nothing to be gained by doing that. I already have type inference. Why would I use type inference again? And the answer is that there is one particular case where this actually makes sense. And that is if you are using an annotation on your lambda parameter. If you do that, you need to have an explicit type in the parameter. So you can't simply say @NotNull on S. You need a type involved there. So you could use the explicit type and you could say @NotNull string S, but if it's a more complex type and you're not quite sure what's happening in the stream, what type is likely to be used, let the compiler figure it out for you and say @NotNull var S, and if it's something more complex than a string, the compiler will figure it out and put that in for you. Small change, not probably going to affect a lot of people's code. Next thing that was included in JDK 11 was the idea of launching a single file source code. Now, in the past, Java has quite a high bar in terms of getting your first program running. Because if you think about, if you just want to write the most basic hello world application, you've got to create a Java file, then you've got to create a class, hello, then you have your public static void main, parameters are going to be string, brackets, args, then you've got system.out.println, hello world. Once you've done that, you've then got to compile the code using java.se, then you get to run it using Java with the class. And if you look at JDK 10 and earlier, there were 3 ways that you could launch a Java application. First of those is the sort of most traditional one, which is using the class path. So we could specify Java, name the class, and the JVM would execute whatever main entry point was in that class. If you want to use a jar file, you could create a jar file with your class in it with the main entry point, and then you could set up your jar file so it was executable, and you could launch that with java-jar and the name of the jar file. And then the third way for more modern versions of Java since JDK 9 would be using the module path and saying java-m and the name of the module that contains the main entry point. In JDK 11, we have a 4th way of doing this. So now what you can do is something like this. You can say java factorial.java 4. In this case, the JVM is going to look at the parameter you specified, factorial.java, and it's going to say, this file does not have the right magic number at the beginning of the file, indicating that it's a class file. It will recognize that it is Java source file, and it will say, okay, in this case, I'm now going to compile that using java.c, and assuming that there are no compilation errors, I'll then execute the result of that, passing the parameter 4 to the main entry point and execute that class with the main entry point. We can take that one step further and we can use shebang support. So in this case, let's say we're running on Linux. What we can do is we can create our file, we'll call it factorial. That's going to have all our Java source code in it. And then at the top, we'll put #bang, where to find the Java executable. We add an extra command line option, source level 11. And then if we make that file executable, we can simply do /factorial for the Linux operating system. Will look at the first line, it will say, okay, execute Java -source 11 with the rest of the file. The Java virtual machine will then look at that and go, it's source code, I need to compile it, generate a class file, and then execute that class file and generate the results. So it's a nice way if you want to just have a single source file and be able to run that without having to do the compilation yourself, then it's just a little bit easier to do that. Only works with a single source file, but obviously if you want to add lots of libraries and things, you can do that through the class path or the module path, and that will work quite happily. APIs that were added to JDK 11. Again, there are lots more than this in terms of some sort of more esoteric ones, but these are the ones that I picked out that were sort of more interesting. So there's some new IO methods, specifically around input stream and output stream, null input stream, null output stream, and the sort of matching reader and writer methods, null reader and null writer. What this allows you to do is effectively the same as /dev/null in the Linux operating system, which says that, if you use the output stream, you can throw as much data at it as you like and nothing will happen. And if you read from either the null input stream or the null reader, you will always get precisely 0 bytes. Now you might look at that and think to yourself, okay, not really sure what the use of those are. And I must admit, when I first looked at those, I thought to myself, I've been using Java for better part of 25 years and I've never actually needed these methods. But it turns out that if you're doing things with streams specifically and some of the more sort of functional style of programming, that there are situations where having a null input stream or a null output stream can be very useful. And so they provided them for that particular usage. The other method here, again, on optional, there's a new method called isEmpty, which funnily enough is the opposite of isPresent. And so will return true if there is a null reference inside your optional. String has some new methods. So even though string has been around right from JDK 1.0, it's still being updated and there's still some ideas for improvements. New methods, first one is blank. Pretty obvious what that does. It will return true if the string is blank. Second method, lines, will return a stream of lines from your string. If there are line breaks within the string, then it will divide up the stream based on those line breaks and return a stream of the individual lines within that string. Repeat will do exactly what you think, which is to repeat a particular string a number of times. And then there are three methods called strip, strip leading, and strip trailing, which will remove white space either from the beginning and the end, or just the beginning or just the end of a string. The observant amongst you will obviously go, hang on, what's the difference between strip and trim? Because trim removes white space from both ends of a string as well. The answer to that is how these methods deal with white space, or how they recognize white space. In the case of trim, it uses a very simple definition of white space, which is essentially space, tab, and new line. In the case of strip, and also strip leading and strip trailing, they use the Unicode definition of white space, which includes a whole range of characters which you probably didn't even know existed, things like vertical white space and things like that. Probably my favorite feature in JDK 11 is predicate has a new static method on it called not, which takes a predicate. Let's see what that does. So here I've got a simple piece of code where I'm filtering my stream of strings and I want to remove blank strings from that. So I can use filter and lambda expression which says string s and remove ones that are blank. I could change that and use my new predicate not method and say filter predicate not, and then pass in the predicate that I want to use, which in this case I'm going to use the method reference, string is blank. And then I can make that even simpler by using a static import of the predicate not method, and I end up with filter not string is blank. And so it just makes the code a little bit more easy to read, a little more understandable, because it's more kind of plain English, if you like, rather than having to look at the individual code and figure out, oh, hang on, I've got the bang there, which means it's not, and just easier to read. Big thing in JDK 11, not just the addition of features, but also the removal of features. If we go back to JDK 9, there was a change in JDK 9 in the sense that Oracle decided that it was time to start tidying up the JDK. JDK was, at that point, over 20 years old, and lots of things had been added, but nothing had ever been removed. We'd had deprecation right from the very beginning, but nothing that had been deprecated had actually been removed. So they've started to gradually remove some of the older things that people really aren't using anymore. And one of those things is what's called an aggregator module, java.se.ee. And an aggregator module is one that doesn't contain modules itself, but doesn't contain packages itself, but only contains references to other modules. In this case, there are 6 modules, which are more related to the enterprise side of Java. And the decision's been made that to keep java.se focused purely on the core part of Java, it makes sense to remove these particular features, especially since they're, again, quite old and not many people are using them. So one of the things that's disappeared is Corba, Common Object Request Broker Architecture, very popular back in the mid-1990s, really not been popular since about 2000. So not many people are using that, and that's gone. Bean Activation Framework, again, that's been removed, probably won't affect too many people. XML binding is the JAX-B API, the way that you can map between Java objects and the state of those objects and an XML representation of that and back again. And then the one that does catch out a few people when I've talked to developers about this is the JAX.ws API. That's Java API for XML web services. And this is the older style of web services where we use SOAP and WSDL rather than the more modern RESTful web services that we all use nowadays. Most of these are pretty easy in terms of replacing them. You can, if you're using Maven, you can just update your POM file. And in the case of everything but Corba, there are versions available through Maven Central. And again, with everything except Corba, you can just download the reference implementation if you want to and use that. So it's reasonably easy to get around that problem if you're using any of these features. JDK 12. Again, another 6 months of development. What did we get in JDK 12? Well, interesting thing here. One of the things that was introduced in JDK 12 was a preview feature. And a preview feature is a new idea in the JDK. What a preview feature does is allow the developers of Java to add a new feature, but without making it part of the java.se standard. The reason for that is that although the developers think that they've got all the right ideas about this and they're sure that this is exactly the way that it should work, what they want to do is make sure that the people who are actually going to be using it, you the developers, are happy with the way it works. And by not making it part of the standard straight away, it allows them to make changes easily in later versions without having to go back and change the standard as well. So as a preview feature, it's not part of the standard, which means you need to specify an extra command line option to enable preview features both in compilation and at runtime. Now, this was the first one that was added, and it's switch expressions. So switch expressions are an extension to how the switch statement works. Switch statement has been in Java right from the very beginning. And the issue, if you like, around the switch statement is that some of the syntax that's used there can be a little bit clunky and a little bit harder to use and more error prone than we would like. A couple of examples are the fact that every case statement needs to be separated. And the one that does seem to catch out quite a few people, I'm sure I'm not the only one who's been caught out by this, is having to remember to put a break statement in every block of cases that you have. And if you don't do that, you fall through into the next set of case statements, and that can lead to some very difficult to find bugs because you're looking at it going, well, it can't possibly get to that piece of code because it doesn't work with that switch statement. And then you finally go back and you go, I forgot to put a break in, and then you do that and everything works. So it's things like that. Plus the fact that local variables, the scope of those variables is not always as intuitive as we would like. So here's a very classic way of using the switch statement that we've had in Java right from the very beginning. What we want to do is we want to switch on a particular variable, and then based on the result of that, and effectively a switch statement is a multi-if then else type of statement, depending on what the value of that variable is, we want to assign something to another variable. In this example, I'm switching on the day of the week, and then I want to assign a value to the number of letters based on what the day of the week is. Obviously, in the case of Monday, Friday, and Sunday, number of letters is 6. In the case of Tuesday, it's 7, and so on. As I said, this is code that is more error prone than we would like because we have to remember not only to put a break in each set of case statements, but we also have to remember to make the assignment to number of letters. And if we forget to do that, we could end up with some, again, harder to find errors than we might like. In JDK 12, we get a different way of doing the switch expression. We get the switch expression. So now we can assign the result of that switch expression to our variable number of letters, and we only need to do that once. So we don't have to worry about forgetting to do it in a particular set of cases. We do it once, and it's nice and easy to see where it's happening and no problem in terms of creating errors. So we switch on the day and we do exactly the same thing effectively that we did in our existing code. And what you can see here is that the developers of this particular feature have realized that there is this incredible piece of technology available to them that has never been used before, which is called a comma separated list. So rather than having to have separate cases for Monday, case Friday, case Sunday, Now we have a nice simple single line, case Monday, comma, Friday, comma, Sunday. And then they've used some of the syntax from the lambda expression, the arrow operator. And what happens here is that the right-hand side of the operator is the value that is returned from the switch expression and assigned to number of letters. So Monday, Friday, Sunday is 6, Tuesday is 7, and so on. And if we need to, we can obviously throw an exception if required. If we want to, we can combine the old style syntax with the new style syntax. And so we can use a switch expression where we can assign the value to the number of letters once, but we can keep our case Monday, case Friday, case Sunday as separate ones. This time, in order to determine which value is returned by the switch expression, we use break 6, break 7, break 8, and so on. Now, break can be used with a label, so a label can't start with a number, so there's no confusion in terms of the syntax between breaking with a number, which returns a value from the switch expression, and breaking with a label, which would jump to wherever that label is in our code. We can also be a little bit more complicated, and we could use code blocks if we wanted to. And so here I've got an example where we've got two cases, case 1, case 2, and because there's more complex code required, we've actually put a block of code in braces. And the important thing here is that having mentioned the scope of local variables, we can use the variable x in both case 1 and case 2 without any problem. In the past, if you tried to do that within a switch statement, then you wouldn't be able to reuse x in both case 1 and case 2. Personally, this is an example which I use to illustrate that we can use the same variable in both case statements, but I wouldn't write code like this. When we have complex code that needs to be put into a block, I would extract that out into a method and then call the method to make it simpler to understand what's actually going on. Streams has a new collector in JDK 12 called teeing. What does teeing do? Well, teeing takes 3 parameters. First 2 are collectors, and the third one is a by function. And to illustrate what happens, I've drawn this little diagram here. We take the input stream, and the input stream is duplicated so that the same set of values is passed to both collector 1 and collector 2 that are specified as parameters to the collector. The results of those collectors are then passed as parameters to our by function. By function takes 2 input values and returns a result. So the result of the by function is what is actually generated as the collection at the end. And to make that a little bit more obvious, what we can do is look at a simple example here. What I'm doing is I'm taking a stream of numbers, 145217. And then I'm just going to pass those into the collect terminal operation, and I'm going to use the new teeing collector. Again, I've statically imported that, so I'm using teeing. The first collector I use is summing double, so it will take the values on the input stream and add them all up to give me a total of the values on the input stream. The second collector is counting, so remember that we have the same set of input values on both collectors. Counting will tell me how many elements I have on the input stream. And then I pass those 2 results, the sum and the number, to my by function, which then divides one by the other, and that effectively gives me the average of those input values. Obviously, I could have done this using a single method call, but it illustrates how the teeing collector can be used. And clearly you could use more complex calculations in terms of what you're doing, but it gives you the idea of what can be done with the teeing collector. JDK 13, bringing us right up to date with the current release. What did we get in JDK 13? Well, I have to say that JDK 13 was probably one of the lightest, if not the lightest releases that we've had in terms of new functionality. Not a bad thing, but just something to be aware of when you're looking at which version to move to. Big thing in JDK 13, if you like, is text blocks. And again, this is a preview feature, meaning that it can be changed in later releases if people think, the syntax needs to be slightly different to what it is. In Java, we've always had the idea of being able to define strings, but the problem we faced is if that string wants to include a new line, then we can't simply do it by putting the text in our code and having new lines embedded in that. So we have to use certain techniques like using \n and various things like that, and concatenating strings. So what a text block allows us to do is, rather than using a single double quote as the start of our string and a single double quote as the terminator for our string, we now use 3 double quotes as a start and 3 double quotes as a terminator. Everything that follows the starting set of double quotes is treated as part of that string, and that's new lines, escape characters, and all the things that we would normally see there is part of the string, up to the next set of triple double quotes. If we want to put a triple double quote in our string, which is quite reasonable, then we must escape at least the first of the 3 double quotes. We could escape 1, 2, or 3 of them, but we must escape at least the first one. So that allows us to do something like this, where we can have some HTML code and we can put that in and we can see, okay, it's indented and everything, so this is all good. If we print that out using our print line statement, what we'll actually see, this is aligned with the left-hand margin. So the space that we've used to indent the string has been removed, because clearly if we're doing something like this, we wouldn't necessarily want to have all the text that we're putting in our string aligned on the left-hand margin, because it makes it harder to read in the editor. So we need to move it over to the right, but we need somehow to identify that some of this text, some of the space needs to be deleted, but not all of it, because of course you've got indentation between the HTML, the body, and the paragraph. So in this case, what we do is we have what's called incidental white space. Everything up to the closing double quotes in terms of spaces is treated as incidental white space, and that will be removed from all of the lines above. That way, when we print out our result, we get our nicely indented text, but it's aligned on the left-hand margin. Interestingly, because we put the triple double quotes on the line after the HTML, we do get an additional blank line. If we wanted to, we could control the amount of incidental white space that we get. So let's say that in the case of this HTML block, we wanted it indented by 2 characters, then what we could do is move the closing triple double quotes to the left by 2 spaces, and that would then reduce the amount of incidental white space that's removed from all the lines above. If we put the 3 double quotes directly after the HTML closing tag, then we would eliminate the blank line as well. So there's a few things that you need to be aware of in terms of how code blocks work. Switch expressions. So you look at this and you go, he's already told us about this. What could he possibly say that we already don't know? And the answer is that in this case, this is a very good example of where things were changed because of feedback from users in the community. So I said that we could combine the old style syntax of the switch statement with the new switch expression. And so we could have separate case statements and then break with 6, break with 7, and that's what was returned from the switch expression. People said they didn't like that because of the potential confusion between breaking with a value and breaking to a label. So in JDK 13, that was changed. And now, rather than using break, we use yield. So there's a distinction between yielding a value from the switch expression and breaking, which could go to a label and continue execution from there. Nice example, as I said, of how the preview feature allows changes without it being required to change the standard. JDK 14. So I thought I'd just mention a couple of things that are happening in JDK 14, even though it's not released yet, because looking at the changes in JDK 14, I think this is going to be a very popular release with developers because it's got 3 in particular nice features that are being added. First of those is records. So records is, again, a preview feature, so we're not 100% sure this is how it's going to look in the final version. What this allows us to do is to really simplify if we have a class which is really just about encapsulating some values. We don't want to do a lot of additional behavior associated with that class. We're looking at just encapsulating some values and being able to access them. Point good example. So it has two values, int x and int y. Now, if we were to do this, writing the full set of Java code, we'd end up with class, a public class point, then we'd have a constructor, we'd have instance variables int x, int y, we'd have a constructor which took int x and int y, assigned those values, we'd have to have accessor and mutator methods, getter setter methods for both x and y, lots of code for us to write, just to have effectively a tuple. In the idea of records, we specify it like this. So we say record point, int x, int y, and empty braces. The compiler will then, in effect, do all of the work for us, and it will generate all the extra code that's required so that we can treat this in exactly the same way as if we'd written it longhand and allowed us to, have two values associated with the particular class. We can be a bit more sophisticated if we want to. So we're not limited to just basic idea of values encapsulated in a class. In the case of a range, we might want to have two values, again, low and high. But in this case, in our constructor, we want to place a check to say if somebody provides a value of low, which is greater than the value of high, it doesn't make any sense, so we want to reject it. We can do that by specifying record range, and then we specify the values that are going to be within that particular record. But now we can also say that for the constructor, public range, we don't need to specify the fact that it's going to have values passed to it of low and high, because we already know that. But we can specify the behavior associated with that constructor by saying, okay, within the braces, we'll put our test, if low greater than high, throw a new legal argument exception of bad values. So it's a nice flexible way of doing things. Like I say, I'm really looking forward to this. This is the fact that we finally get a tuple in Java is just wonderful. Pattern matching, again, a preview feature. So what does this do? Well, often we need to be able to look at the type of an object using instance of, and then do something based on what that type is. So we would do something like if obj instance of string, and then what we would have to do is we would have to assign object to a string, say s, but we have to do an explicit cast to make that work. With pattern matching, what we can now do is a slightly different syntax, which says if obj instance of string, and then we specify a variable name, s. If obj is an instance of string, then it will be assigned to s, and within that block of code, between the braces, we can use s as a string. We don't have to do the explicit cast, we don't have to do the explicit assignment, compiler does that for us. So here we can print out s.length, because s is a string, we can call the length method on it, it works absolutely fine. The scope of s is limited to where that if statement is. So if we look at the else, we couldn't use s within that else, because s only applies within the true branch of that if statement. If it isn't a string, then clearly we don't want to be able to use it because it's not a string, so it's not usable. And then the third thing that I'm, again, really excited about in terms of this is going to be so useful is helpful null pointer exception. And I do like asking audiences when I do this presentation live as to, has anybody here never had a null pointer exception? And of course, everybody has. So null pointer exceptions, they do happen fairly regularly, and we have to cope with them when code doesn't quite do what we expect it to do. But the problem we face is when we do something like this. So again, very standard piece of Java code, a.b.c.i equals 99. If we make that assignment, we could have a problem, because if part of that statement results in a null pointer, we get a null pointer exception. And we'll see something like this, where we say exception in thread main, Java lang null pointer exception at line 5. Okay, that's great, except it doesn't tell us what caused the error. Was it A that was null? Was it B that was null? Was it C that was null? Because if any of those things are true, then we can't reference through it to get to the next part of the statement, and we get a null pointer exception. If we then want to go and figure out the way to solve that problem, we're faced with either using a debugger, or we have to go back and we have to separate it out. We have to start doing like print A, print B, print C, and figuring out where the null is. Way too complicated. Now, in JDK 14, hurrah! Exception in main thread, Java lang null pointer exception, cannot read field C because a.b is null. Immediately we know what the problem is. Okay, it's a.b is null. How did I get to that point where I didn't assign a value to b? Oh, look, I forgot to do it further up in my code. Rectify that problem goes away. So suddenly it makes finding some of these problems and fixing them way easier, and I'm just so happy about that. Okay, just to finish off, I want to say a few words about what we at Azul do in terms of Java. We have this thing called Zulu Java, and Zulu Java comes in two varieties. The first is what we call Zulu Community. Now, this is our free build of the OpenJDK. Did I mention it was free? So what we do is we take the OpenJDK source code and we build that into a binary distribution so that you can use it to run your applications. It uses the same license as OpenJDK, so it's GPL v2 with class path exception, means you can use it wherever you like, there's no restrictions, and again, it's free from our website. The important thing is that we also run all of the TCK tests on that binary that we create to ensure that what we've built conforms to the java.se standard. And that's about 150,000 tests to make sure that what you get is going to run your applications in exactly the same way as other OpenJDK binaries that have also passed TCK. In terms of availability of versions, we actually go all the way back to JDK 7. We have JDK 8, 9, 10, 11, 12, and 13. I believe we may have 14 coming out as early access very soon as well. We have wide platform support. If you're using 64-bit Intel architectures, we've got Windows, we've got Mac, and we've got Linux versions. If you want to use some slightly older operating systems, if you're using like Windows XP 32-bit or something like that, then we also have Intel 32-bit versions for Windows and Linux. And if you want to use something like a Raspberry Pi, then we have an ARM32 version and ARM 64-bit version as well. All of these are available. I did mention it was free from azul.com downloads Zulu. If you are looking for more commercial support, then we can also provide that to you as well at a very reasonable price. And what we do there is we actually do backporting of the updates from the current release of the OpenJDK, because Oracle only contribute changes to the current release of the OpenJDK project. We will backport those to all of the long-term supported versions, which for us is currently 6, 7, 8, and 11. And we will make those available under a service level agreement, which is part of the support agreement that we have. In terms of JDK 8 or Zulu 8, that's going to be supported until March 2026. We've just recently decided that we're going to extend support of JDK Zulu 6 until the end of 2021, because there are still people out there using JDK 6 who want to get updates. So we're going to continue doing that for a while longer. In terms of what we're doing, we will follow the same long-term support release pattern that Oracle are doing and everybody else in the OpenJDK distribution business is doing. We intend to have 9 years of what we call active support, which is where we will backport all updates every quarter, and we will make those available. And then we have a further 2 years of what we call passive support, which is where we don't provide regular updates, but if there is a problem found, we will find a fix, assuming we can find a fix, and we will then generate a new binary and provide that to you. Something else we're doing is what we call medium-term support releases, because we think that 3 years between long-term support releases is quite a long time, and there may well be people who want to use one of the intermediate releases because there's some nice features like we're seeing in JDK 14 that they want to use in some of their applications. So for us, 2 of the interim releases between long-term support releases are going to be medium-term support ones. What we're looking at the moment is JDK 13 and JDK 15. And those will be supported with updates until 18 months after the next long-term support release, to give you 18 months to move from either 13 or 15 to 17. So just to summarize, Java continues to evolve. It's really good, having been involved in Java for the last nearly 25 years, it's really good to see that there's still a lot of activity in making Java better and making sure that developers get the features that they want to keep it a very popular and a very fresh programming language and platform. So we have switched to this faster 6-month release cycle, and it does mean that we're actually getting to see lots more features more quickly than we did before, and that is a very noticeable effect in terms of what we're seeing with the individual JDKs. There are lots of other ideas for improvements to Java. There are some bigger projects with longer term goals, things like Valhalla, things like Panama, things like Project Loom for well, it used to be called Fibers, it's now virtual threads. Valhalla is about inline methods, used to be value types, and Panama is about a replacement for JNI. So there's lots of things going on in that space that are interesting for bigger projects to change Java. And as I said, Zulu Java, it's a free version and also a commercial version if you're looking for that kind of thing. So with that, that is the end of the webinar part of things. So what I'll do now is I'll switch to the, go back to the webinar side of things and see what we've got in the way of any questions if we do. So, right. Right, okay, so somebody had a problem with the audio. I'm afraid I can't do much about that. Right, question. I thought you could run a single file of Java code with JShell in a script. What's the advantage of launch single file source code with Java as opposed to JShell? Yeah, I mean, it's a different way of doing it. So yes, you're right. I mean, you could use JShell in a script. That is definitely a way of doing it, but I guess it's a slightly simpler way of enabling the ability to run a single file of Java code rather than having to use JScript and do it that way. So it's a similar thing, but I personally don't think that's a huge feature. It's one that's nice for a little bit of prototyping, but it's not really going to make a huge difference to anyone who's developing an enterprise application. It's more about helping to get people started more quickly. So I'm not seeing any other questions. If anybody's got any other questions, please feel free to type those in. Otherwise, I'll give people a couple more minutes to see whether any other questions come up. But I'm hoping that my explanation of things was so clear that there just aren't any other. Oh, there we go. Hang on. Thanks for the presentation. Okay, that's good. As Stephen said, you will get a copy of the slides, so there's no problem with being able to go back over that. We also get a recording link so you can listen to it again or share it with your colleagues, your friends, your family. Okay, so yeah, I'm not seeing any more questions as such, so I will thank you very much for listening to the presentation. And if you do have any questions or comments, you can see my Twitter handle there, Speak Java, and please feel free to contact me through there as well. I do leave DMs open so you can reach me without any problem. With that, oh, hang on, I see one question here. Can we discuss more on module and package features that came in Java 9? I deliberately didn't go into Java 9 with modularity because the length of the webinar means that to add that in would take longer. If you go online, you'll find that I did a presentation last week at the New York Java SIG. It's on YouTube. It's called After 8. About Java, and I do go into a bit more detail about the module side of things there, so you can watch that video. Unfortunately, I don't have time to really go into that now. Okay, so since I don't see any more questions, I will thank you very much for listening.